Okay, welcome to the first tutorial in our R series. My name's Rick, and I'm going to walk you through some of the things that you'll be doing in the course, starting with just basics of R and R Studio. So what you're looking at now is the site I've got put together for you, which has all the tutorials listed down the side here. We're going to start with the basics one today, and in subsequent weeks, you'll watch some of the others. Before we get started, the most important thing about today's tutorial is actually downloading and installing both R and RStudio. Those are two different things if you're not familiar. So R is a statistical programming language. It's installed on your computer. It can actually be accessed through the command prompt, through other means besides a graphical user interface, but that's how everybody does it now. So um, R is hosted by the Comprehensive R Archive Network, or CRAN. That's where you can download and install the newest versions. You would navigate there, pick the version that you need. So I use Mac OS. The most recent version is always shown to you up at the top. It's a package. So you download it just like you would download any other Mac software. You click on it and it'll start a download. And then once it downloads, you would click on the package as usual, and the installer would open, and you'd be on your way. The nice thing about using R on Mac is that's all you have to do to install R. Mac is equipped with everything else that it needs. In some cases, you may want to install some of the coding tools, Xcode on Mac, but that's not required for this course. If you have Windows, the process is a little bit trickier. So if it's the first time you're installing R, you're going to install base R. So you would click on that, and it's again version 5.4.2, and it's an exe file, and it would be the same as installing any other program on your computer. You may run into a situation in which you also want R tools. Now, packages are different, so what you'll start to get familiar with the terminology of R code. One of them is that users, because R is open source, anybody in the world can create a new package, which means it's a bunch of new functions, new code that's used to do specific stuff, and we'll use a number of them in this course. So unfortunately on Windows, sometimes you need R tools as well to run some of those packages. So I recommend that you do try to download R tools. So you can probably do either 4. 4.4 or 4.5, either one should work well. You may have some of you that are using machines that belong to your work and may have extra permissions. It may be an issue. So the the main point is to try to do this as soon as possible and make sure that it works out. So once you've done all that, so assuming that something worked for you, and you've got we call this sort of base R, or just R itself, the actual language, environment, everything installed on your computer, you would then go to uh, what's now called Posit. It used to be called RStudio, but our RStudio, and now the company Posit, has expanded because so many people are using different programming languages altogether. RStudio is still called RStudio, but you can now run a lot more code inside there. Um, the nice thing is that it has still comes with a free and open source version, RStudio Desktop, and so you can usually, like I just got here by searching RStudio, it's the first thing that pops up. Um, RStudio Desktop. If you scroll down, you've already done step one. You've downloaded and installed R. This will just send you back to CRAN if you forgot to go that way. And then install RStudio. So again, it already knows that I have Mac OS. So it just like lots of other things you download on the web, you'll find that this already guesses your operating system. So, you know, I'm on 13 plus or higher because I'm actually on 26. And then boom, pops right up. I click on that. Again, it's a package file. It downloads. When you get it onto your computer, you're going to double click, and it's just going to ask you to drag it into your applications folder. So it's very easy to install. Once you download it, it's basically installed to do a couple of things. Um, and so that's that. So you've got R on your machine and RStudio running. So this is what R will sort of look like for some of you. Actually, it won't look like this for any of you to start. I use it a lot, so I, customize mine. So let me show you what that means. You won't be able to see it on screen, but if I go to File, or excuse me, RStudio, and sorry, if I go to Tools, Global Options, I'll see that I can do lots of stuff. So in appearance, I forget what the default theme is, but you can change. I like the Cobalt theme. You can change different stuff. So I think it comes with a lighter one. So when you download R, it will be white in the background. That hurts my eyes after a while, so I don't use that. The other thing, and I'll go back to the global options menu, that will matter is when you download R, you'll see it as this. You'll see it this way. So you'll see it'll open up this is what's called the console here. So this is just the command prompt, and R interprets all kinds of stuff here. We'll talk about some of it, but very easily, very simply, it's a calculator. So 30 plus 30 is 60. So I can type in lots of stuff here at the command prompt. That's usually pretty tedious. So you'll see here, I've already got something called the script window open. And if I type 30 plus 30 up here and press enter, it doesn't do anything. It's basically a text file. But I'll show you, more about this later. If you select what you've just typed and you click run, you'll see that basically the run button copies and pastes what you've typed up here down in the console and spits out the answer. Scripting, and if you're more advanced, using R Markdown is the way to do things. It keeps everything reproducible. So as much as possible in this course, I would recommend not to type in your stuff down at the console, but instead use script files, because you can save them, open them back up, rerun the code again, and everything is reproducible. So you can play around with all those options. I'm going to switch back to the way I like to look at it. So global options, pane layout, put my source over here and my console over here. The reason I like to do this, if you're curious, is because then I can keep this in the middle of the screen, and this is right here, rather than having to strain my neck and look over to the left, right? So let's talk about what these panes are as well. So the one with this tab, I always call this the environment tab, and we'll see what that does in a minute. But you also have a couple of other tabs here, the history tab, which you might use. This shows some code that I've run in previous sessions. You can also access the history from the console by just clicking the up arrow, and it'll go through lots of things that you just did. So that's really helpful if you make a mistake in typing. So you make a mistake up here and you want to just fix it down here, you can kind of go back and say, oh, I didn't mean 30 plus 30, I meant 30, so I have nothing there. So rather than type 30 plus, like say you meant 300, you could just click the up arrow and add, whatever you want there to it. And you see it keeps track of it in the history. You won't use the connections pane. That's a little more advanced. R comes with tutorials built in, so you can also have a look at those. These are pretty fun. So These are, kind of generic, but if you're looking to do more deep dives, they're always available. So usually we keep the environment up because that's it's going to show us all the stuff that we have available to us in any session. Down below that, you've got another pane which has good stuff in it. So by default, it shows you what's called your working directory, which is where if you are reading in data from an external file, which I'm going to show you in a minute, that's where it's going to live, or that's how you need to get it, as well as that's where the default location where things are going to be saved. So I actually have set up on my computer for it to be in my research folder, but I can change this and I'll show you how to do that. Some other things in this pane are if we make plots, they'll appear in this tab. This tab shows you all of the R packages that you have loaded. So the more and more you use R, you'll see I have about 400 different packages. So this just gives you extended functionality. They're all listed there. The Help tab is going to be your friend. This is where you can find information on some of the functions you're going to use. The Viewer tab I don't use as much. That's if you make HTML. And then same thing with presentation. So you're going to use files, plots, packages, and help a lot. I already discussed the script pane here. This is where you're going to, and by the way, you can save. So if I click save here for the first time, it's the script files are just text files with an extension. Instead of TXT, it's R. Very creative, right? So I could just save this as my script, and you can see by default it opens up to my working directory, but I can change this anywhere I want. I can do my desktop, any other drive that I have available to me, and this is the same on Windows as well. So I'll go ahead and just save it there, and now I've got it saved, and then as I type more stuff in, it'll save it. The other great thing that you want to start to do, and this is every computer language has this. So if I type in here, at the top, something like, this is my script, R is going to get mad at me because this is not computer code, right? So I see that there's an error here. So RStudio debugs your code for you, shows you where there's some errors. And so the reason why this is throwing errors is because you're in a script file, you're not allowed to have anything that's not computer code. If you want to have things that are not computer code, like little notes for yourself, which is extremely highly recommended, you have to put them in as comments. And you do that using the hash or number sign, and you can use a bunch of them. You'll see files that have kind of different levels of, so some of your script files that have been written for you, might have something like author, date. Today is, I'm doing this on January 2nd. I should be, not working, but I am. And, I could do something like intro to R, right, as the title. And you'll see in the code that if I make code for you, that I'll often do like here, multiply by 30, or sorry, not multiply, add 30 to 30, self-explanatory. So anytime you're writing code that's not self-explanatory, so this is self-explanatory, you can insert little comments to yourself to remind yourself. That's even more helpful if you're sharing your code with somebody else. So let's say you're working on a project jointly, and you want to be able to have your friend interpret what you've written. You leave little comments. All right. And then, of course, down here, we've got our console, which the results of what we ask R to do appear at the console. If we're using the script, they'll only appear at the console. If you use R Markdown, results will also appear up here. So we'll keep us with the scripts for now. So what I'm going to show you from here on in is kind of walk through a couple of things that you're going to see if you scroll through the R Basics document. Right? So first things first, I kind of showed you this, that you can type in mathematical stuff at the console. Most things are going to be similar to Excel. You can even type in exponential functions and logarithms. So if I want to do the natural logarithm of 30, and type that in, or raise 30 to be 30 be the exponent in E. I can do it that way. Square root that's the same as it is in Excel as well. So what I want to start to show you is then some stuff that's a little bit beyond that. So first things first, in R, we're going to be doing data analysis. So it's pretty difficult to do any data analysis without some data. So I'm going to walk you through a couple of things that enable you to work with data. So pretty much you're not going to ever be entering data in R. Sometimes for little pet projects you'll do that. But I do want to show you how to do that. So, we'll do it up here in the script file. So I'm going to make what is essentially a column or row in Excel. It's worth of data. So X, and I've just typed something after X. I'm going to name what I'm going to save. Right? Or I could do it as my cells or my data. And then I typed an arrow, but I did it with two different keys. Very, very important. This is called the assignment operator. It's very similar to the equal sign, but it's a little bit different in the sense that what we're kind of doing is we're assigning or storing information in an object called my data. So it's not that what we're doing is saying something's equal to my data, we're assigning it there. For all intents and purposes, the arrow and the equal sign are similar, but you'll see a lot more arrows than equal signs. So to actually do this, it's on your keyboard, it would be Shift and the comma button to get your less than sign, and then it's just the single dash. Right? That's your two keystrokes, less than, single dash. That's your assignment operator. The second thing we need to do is, so let's say I wanted to just store numbers 1, 2, 3, and 4. Maybe you think we might just do it in parentheses, right? Or even without parentheses, separated by commas. Now, you can already see that that's not going to work for R. And if I selected this and ran it, it's going to give me an error, right? It doesn't like this code. Why doesn't it like this? Because it doesn't know what to do with this parentheses here. Actually, it doesn't know what to do with the commas because it expects with parentheses we're just doing arithmetic. So the thing that we need to do to turn this into data is to simply just have the letter C go in front. C is short for concatenate. And so when you use C, what you're doing is creating what in R is called a vector. And a vector is just a list of stuff, usually numbers, all of the same type. So actually, it doesn't have to be numbers, it could be character strings. And so the C function expects a bunch of stuff separated by commas, and I will click run, and now we see it over here. All right, so that's what our environment is going to be for. This pane is going to show us what we have stored. So now let's say I was working for a while and I wanted to use this data set again. If I didn't see it over here, I could actually type it, my data, down at the console, and it gives it back to me. And more importantly, I can do stuff with it. So I could type the keyword sum and my data. And what that does is exactly what you would think, is it adds all of the things in my data together. So it creates the row or column sum, depending upon how you want to interpret that. So we're going to do a little bit more than this. I'm going to go back to my tutorial, scroll down, and we're going to go ahead and make a slightly larger data set. Now, I picked my data for that, so we're just going to delete this. And notice that if you use the same name for a new object, this is a different object, right? This is a numerical vector or array with 4 things in it. This is a numerical vector with more than 4 things in it. If I run this, notice that without a warning, R will paste over, right? So it will delete the old version and update it. So you always want to be careful when you're saving stuff that you don't inadvertently save over something else. Just be aware of that. So what we're going to do is create our own descriptive statistics. So just to show you that things can be done with vectors that we might ordinarily just think we can do with numbers. So let's compute the mean of this set of numbers using what we know about a mean. So a mean is always the sum of a set of numbers divided by how many there are in the set. So I've used 2. We saw this function before. Now here's a new function, length my data. You might guess what that does. If I type it down here, whoops, I copy and paste there. It, for a vector, if you type length vector, it tells you how many things are in it, 10, right? And so that's a sneaky way to just get the number 10, which is the number of things in there, as our denominator. So I select it and run, and now notice it doesn't pop out at the console, right? Instead, I've now got a stored value over here that says the mean of this data set is 3.13. Let's imagine that these are, satisfaction ratings of 10 patients in a hospital ward, with 5 being the best. And so we're not doing so well on this ward if the average patient rating is 3.13. Usually patient ratings are almost uniformly positive, very polarized, with a few very, very negative ones, right? All right, so what else do we usually do with numeric data? We often want the standard deviation. Well, we can do this with commands in R, but just to illustrate to you a couple of different other things we can do manually, you'll see the next bit of code in the tutorial is to first create the sum of squares and then use that to create. So also notice that you can, in the HTML, you can actually copy the entire thing that you see there. So, or you can select, and I'll do it with right-clicking here, copy, and then paste here. I do suggest that you do type stuff out for yourself as well, because you'll just get used to the code. But after a while, it's going to be tedious to type these types of things out. Let's walk through what it is, just so you start to understand this code, right? The sum of squares is the sum of the squared deviation scores for a set of data. It has a computational formula, which can be computed by first taking the sum of the square of each of the members of my data. So if we pull this part out, copy, paste down here, we see that this is how we raise something to a power, is the caret, and we can raise a whole vector to a power. That just means each number in the vector, or if we're using Excel, if we're thinking of Excel, each number in the column, each one gets raised to the second power, or we have the square of each one. It's handy to be able to do that. And then we take the sum of those squared x's, and we subtract from that the sum of the x's, sum my data, to the second power, 31.1 squared, and divide that by n. So just this part here is 97.969. If I select and run the whole thing there, I get the sum of squares for this data set is 14.221. Now, if I divide further by the sum of squares by n minus 1, I get the variance, right? And then if I take the square root of the variance, I get the standard deviation. So here is illustrating another thing we can do in R, which is that within a function square root, right? So first let me compute the variance. So I'll copy this part of it, put it down here, right? I'm taking the sum of squares and then dividing by the length of my data, 10 minus 1. And then I would do the square root of that to get my standard deviation, 1.27 and change. Instead, I can pack all of that part as what we call the function argument or the input to the square root function. And then again, I can save it, right? So I see over here, I've saved the standard deviation for the data set over in my set of values. So the purpose of that demonstration is first to show you if you wanted to give yourself a little toy data set to play with R, at least column by column, you could use the concatenate or C function, and then you can do all kinds of stuff with that just by using what you know about mathematical formulae applied to an entire data set. And again, so this is nothing that's really different from Excel. We're just typing it up explicitly rather than sort of dragging through Excel's interface, right? All right, so if we had to do this kind of stuff all the time, it would take us forever. Fortunately, we don't have to do that. There are a number of functions already built in and then packages on top, more functions that do this for you. So if you have a data set, a column of data, whatever, you can just simply type mean of that data set and it outputs for you. Right? Or you could save it over there if you want. Similarly, SD for standard deviation or variance. By the way, what I'm doing here, if you don't like to click run or copy and paste, you can either select or put your cursor at the front or end of the line that you want to run. So let's say I want to compute the mean again. And on my computer, since it's a Mac, you would do command and then enter, and it runs the code. On a PC, that would be control enter. Control enter will run. So I'll do that as a shortcut a lot because it saves some time. Okay, great. This type of data set is not what you're going to work with most of the time. You're going to work with data that's already been collected and stored elsewhere. R is not usually the place where we enter data or store it, it's where we analyze it. So let's now work on importing data and figuring out how that works. So first things first, to be able to import a data set, you have to first find where it is. So to do that, and the data set that we're going to use is called the nurses data set. Now this should be available to you on Canvas. My nurses data set, I'm going to have to find it, and I can navigate here just like I would normally. So I can go to my home folder. Now all my stuff is in the cloud, so I've got to go to my box, which is here. Let's see, creative. Whoops. Sorry, let me do this again. Oh, actually, I can do it this way. I can find stuff. Oops. Oh, sorry, it's the dots. So I can actually go to the dots and navigate myself to the folder I want. And so I want the tutorials folder, right? And now I see everything here, along with, importantly, the data set that I need, nurses SAV. And so the way to import data is simply use functions that are in here. One of the functions for reading in SPSS data is available through what's called the foreign library, which you will have to install if you don't have it. So anytime you don't have a package or a library on your computer, so you can figure out whether you have it or not. So I have the package called foreign. Right? See it right here. If you don't have it, you can click on install and type foreign. And now if you already have it, it's just going to update it. So I'll install. You see it starting there. And boom, we're done. So you got to install it. You only have to do that once. So you don't have to install every time you use a package, just the first time you use it. Now, in the foreign library, we have, so if I look at foreign again, there's a function called read SPSS. And it's got, you'll see in the help folders that usually there's, they range from helpful to not helpful. Often you'll see like a huge list of what you could think of as options, which we call in the computing world arguments to the function. But that's what they are, is they're options. A lot of them are default and you don't have to worry about them at all. So if we go back to the tutorial here, right, we're down here, and the code that we need to run is this one. We want to read in the nurses data set using the read SPSS function. And notice that all we have to do is supply the name of the data set and this optional argument to data frame equals true. The reason that we have to do that, I'll explain to you in a minute. Importantly, we've also got to, the first time we use any code from a package that's not automatically loaded, we have to use the library function or library command to load all of the code that we're about to use. So I'm going to go ahead and copy this whole thing over here, paste it in there. So the first thing first, I'm going to actually, what we call attach the library function or package. And now I'm going to read in my file. Oh no, what happened? Error, unable to read in nurses, what, no such file or directory. Well, it's here, isn't it? Let's see right there. So you may get this error and then try to throw your computer out the window or in the garbage. Don't do that. There's a very important thing that I skipped, and I did this on purpose just to demonstrate the error that comes up. Right now, R in RStudio, think that you're in a particular folder on your computer, and it's looking there for the files that you might need. Right up the top here, it lists that folder. So on my machine, that's that research folder that we originally were at. Right? And I can click the button there and it returns me to it. That's not where this file is located. The file is located in a different folder. Right? It's in a folder called in the teaching folder here, in courses, 615, R, new content, and finally tutorials. So very, very importantly, what I must now do is go to the gear, click it, and click set as working directory. And now notice it changes, right? So my working directory is now the one I'm looking at here where the file is. Okay, very, very important. So in order to read in an external file without the full path, so you don't have to do this, but this is really the best way to do it. So to keep your code nice and neat and just simply have the name of the file, nurses.sav, as the argument to the function, you must first set your working directory to the folder that contains the file. And you can do that pointing and clicking, right? Navigating in your file pane to where you see the file, clicking the gear, set as working directory. Notice that that's equivalent to writing a command that literally gives the entire full path to that folder, which is kind of not the best way to do it. So the best way to do it is to use the gear. Okay. Now, if I run, boom, I've got my first data set. Now notice it's in a separate part of the environment folder called data. And if I click on this little arrow, by the way, I can move these panes around. I can see what's in it. I can also see what's in it by typing str for structure and the name of the data set there, and it prints me out the same thing at my console. It tells me the names of the variables. Now, if you have a really big data set, so big meaning lots of variables, or in this case, we can also click on it and see it exactly as we would see it in SPSS or Excel, right? Variable names up the top, row names down the side. We've got a bunch of different things. This is a simulated data set from a textbook actually on multi-level modeling where we've got nurses clustered in wards clustered in hospitals, and a couple of different things about the nurses that we're going to step through in a minute. This data object in R is called a data frame. And a data frame in R is, for all intents and purposes, just like what your data look like in Excel and SPSS, with some fun things to add on to it, which is that it can interpret coded data. So if we were to look at this data set in SPSS, we would see for the ward type, gender, we'd see numeric codes. In our data set, when we look at that, we actually see text. So we see male, female. However, this is not encoded as male, female. It's actually encoded as 1, 2 with labels male, female. And it's an important difference, as you'll see later on in the course, between a character variable, which is just, strings of letters, and a factor variable. I'll explain that difference, later on. Anywho, now we've got data in R, and we can do even more fancy stuff with it. So oftentimes data are distributed, somebody's worked on it in SPSS, entered it in SPSS, that could be imported into R using read SPSS. Other times, the way I like to archive my data is as a CSV file, sometimes as an Excel file. There's a native command called read CSV, which is does not require a special package. It's really easy to use. It reads the file in exactly as it is in CSV. There are various other functions to read in Excel files. You'll get used to different ones, although a lot of the data in this course I've actually tried to, there's a lot of data that's distributed with R packages so that you don't even have to import data to R. You can also export data out of R to various formats. So just make it a little bit easier for you. All right, so we're going to stick with this data set, and we'll step through a few more parts in the tutorial. I'm going to skip over this part, but I want you to pay special attention to this section 1.6.1 and everything from there down to 1.7. It's going to talk about the different ways to tell R that you want to use a specific column in your data set. That's the selection operator, matrix indexing, and then the column name. You'll see a mix of different ones, and so I just want you to know what that means. Okay? So we're going to just quickly, to finish up this little lesson, I'm going to talk about a couple of things that you'll see over and over again. So that's creating frequencies and contingency tables, descriptive statistics, and some data visualization. So first things first, the table function is really helpful. and we're going to use, that's what you'd want to use to summarize categorical data. So if we want to know how many males and females there are, we would type table nurses, and here's where we need a way to access the, so if I do table nurses, right, it's going to get mad at me because it thinks it wants me to make a, a very large table out of the whole data set. That's not what we want, right? We want just one single variable. So nurses, and we type the $, and RStudio is great. We could actually just go in and select gender, or I could, in the old days, we used to have to type gender, or let's say you type that, you can press tab and it fills it in for you. And now remember, I'm typing Command Enter, which on Windows would be Control Enter. And down here, I get my table. Right? That's 265 males, 735 females. There's another function for tables that does not require to use the $, but it introduces you to what's called the formula interface, and that's XTabs. The formula interface in R utilizes the tilde, which on everybody's computer should be Shift and then the key next to your number 1, little tilde. And that usually refers to on something or whatever. Anyway, we'll save that for next week. You're going to start to see that a lot more. What we want to do with XTabs is after the tilde, type the variable name that we want to tabulate, and then very importantly, we have to type the name of the data set. Data equals nurses. And I basically get the same result. Now, what's different about XTabs is I could now see the breakdown of nurses with respect to another grouping variable, let's say ward type. So if I type plus ward type, I'm now going to get how many males and females within the 2 factors of ward type. So for the general care wards, there's 134 males and 365 females. In specialty care, it's about the same. So this is our 2x2 contingency table. So XTabs, it's what the workhorse for contingency table. As you'll see in the tutorial, then there are a couple of ways to turn these counts into percentages. The easiest way to do that is to actually save a table. So we're going to save this object as GenTab. I see it over here, GenTab. And we're going to pass that to the prop table function. Now, by default, what it does, if you just type that, is it gives you so if I sum the whole table, which should be on 1,000, because there's 1,000 people, so sum gen tab tells me 1,000. So notice it's just each of these numbers divided by 1,000. Sometimes that's what you want, but let's say instead what you want is you want to condition on one of the margins, or excuse me, get the marginal condition on one of the margins. So first we'll condition on the row. So given the gender, what is the so given that you're male, what percentage of the males are in general care versus specific care? So we do that with prop table gen tab margin equals 1, right? So we're going to condition on the row total. So out of the total number of males, what proportion are in general care, special care, same thing for females. Okay? So these two numbers this way should add up to 1.0, right? Whereas if we do it another way, so here's a nice use of copy and paste. Let's say instead I want to know if I condition on ward type, what's the spread of the genders? I do it this way, and now the columns will add to 1.0. So in general care, there's about 27% male, 73% female, and it's pretty much the same in specialty care. So that's how we do our contingency tables and our proportions. For numeric variables, of course, we want our usual things: mean, median, mode, standard deviation, variance, range, so on and so forth. To do that, there's a fantastic package called the Psych package, which again, if you're doing this the first time, you're going to want to go back to your packages pane, install, type Psych. And now again, I have the package, so it's just going to update it for me, which is nice. And within that package, there is a function called describe. Now again, since I have not used the package yet this session, I've got to put my library command in there. Now the best practice is to put all your library commands up the top of your script. So a lot of times you'll see scripts where load packages, and then you'd have library read, foreign library psych. So that you know that when you want to do this analysis again, you need to use these two packages. You load them right away rather than having them lurk down here in your code. But we're going to keep it this way. Load the library, the psych library, and the workhorse of this one is the describe function. So it does what it sounds like. It's basically a clone of what you would get in SPSS. So again, you have to pass it particular columns in your data set. And so I'm going to use a different method for doing that. So this is called matrix indexing. So I use the square brackets, and this is often awkward. You're going to have a blank space and then a comma, meaning to leave this part blank means I want to use all of the rows in the data set, meaning all of the observations. So you can subset the data, like you could do 1 to 500 if you just wanted the first 500 observations. Normally we don't want to do that. So you'll see that kind of awkward weirdness. So nothing, then a comma, and now I'm going to put in a vector the names of the columns that I want. So again, I'm following along in the tutorial. I'm going to use age, Experian, and stress. So notice this has to match exactly what it says there. And notice that I put them in quotes and they've turned green. That's done on purpose, right? If I instead didn't include the quotes for at least one of them, R is going to get mad at me, right? It thinks if you put something not in quotes, it expects that it's a value, right, or an object. So you have to put it in quotes to say, no, 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 no. This is actually within the nurses data set, one of the column names. Right? So I'll run this. And exactly what you would expect down in your console, you get for each variable that you included. We've got number of observations. This is helpful if you've got missing data. It'll only give you result. The ends will be different. So if you had missing data in this data set, so let's say you were missing age for like 81 nurses, this n would not be 1,000. It would be 1,000 minus 81, which is should have given myself an easier answer. 919, I believe. So it's a good way to see if you have complete data or not. So then we've got the mean, standard deviation, median, a trimmed mean, mean absolute deviation, minimum and maximum values, the range, skew, kurtosis, standard error of the mean. So some of these you'll never use, like trimmed and mad, most likely, but they're there. Another thing you can do is get the so-called 5-number summary using the quantile function. You can only do this one variable at a time. So nurses, so let's say I wanted the 25th and 75th percentile for age. I'd have to type it in there and I'd see that it's 33 and 53, right? The median matches and the minimum and the maximum match there. If I want those additional quantile points, I got to get them through a separate function. We can additionally condition on another variable, or basically get age, experience, and stress broken down, say by male, female. Right? That's another function in the psych package, describe capital B by. And it takes the same input, right? So we've got to pass it a set of columns, but now it has an additional argument, group. And unfortunately, this requires you using the selection operator. So we want the grouping variable is the variable we want the values broken out by. So nurses, select gender. And so now I see something similar, but I've got the descriptive statistics for males and females broken out, and then the same thing here. And so that's where we can start, asking questions like, oh, I see that, this number, the average stress for males is higher than females, and then we could do a statistical test to, make an inference about that difference. Is it actually, quote unquote, statistically significant, so on and so forth. We can do it by ward type, as you'll see in the tutorial. And we can even do it by 2 or more. So let's say we wanted to do male, female, and break that out by ward type. We can add to the grouping argument there. All right. So one more thing I do want to show you, you can add a variable to a data set. So let's say you wanted to, we've already got z-scores for everything in there. So let's say you wanted to just make sure that they were correct, or there wasn't one in there and you wanted to add it. The way to do that is to type first the data set and then the selection operator, and now name your new variable. So we'll just name this Z age 2. Make sure it's not something that's already there, or you're going to paste over it. And then I'll just do the usual z-score computation. So I'll take the nurse's age, subtract off mean, nurse's age, and then divide by the standard deviation. And so now if I look at my data set, I've got a new column that wasn't there before. It just so happens to be the same as one of the other columns. That's fine. So you can add columns to your data set simply by using the selection operator, naming the new column something that doesn't already appear in your data set, and then computing what you need to compute. All right. So real quick, I'll also just take you through a couple of the basic visualizations. So if we want to, usually we want to see, a histogram. That's a base R command, hist. Again, we've got to use the selection operator. And you'll see it pops up in my plots pane. Now I can make the plots pane bigger if I want to zoom in. There's also arguments, so we can go in and change. So by default, it picks how big the bins are. If we wanted to change that, we'll see that I think breaks 20. The breaks argument will change the resolution essentially of the histogram. So now it counts up so breaks just changes the size of the bins. So now we have more bins. So there are 20 dividing lines here between the bins. Instead, I can ask for bins at specific ages and stuff. Usually the default is just fine. There's something called a density plot, which is really nice. You have to use the CAR package for that, which some of you if R tools doesn't work on a Windows machine, doesn't always work. So you can install that as well. I'll just imagine that you did it. And so I would do library car and density plot. Experian. Actually, we'll do it age. So that's just sort of the same thing, but instead of using a bar plot like the histogram does for frequency, this is density. So it's sort of approximating the probability distribution that might have given rise to the data. Again, we see some bumpiness there. We're also familiar with box plots. That's we can do box plots using simply just the selection operator. Or even more fun is we can, which is what you'll usually do, is to do use what's called, again, the formula interface that will be discussed next week, and do one variable. So we'll make a box plot for, let's say, experience. And we do that by the levels of ward type. And now they're labeled, which is really nice. So you can do that. Usually it's 2 at a time. Finally, your basic scatter plot is going to use the plot function. And the basic way to do that is to pass the x variable first and the y variable second. So nurses age and nurses Experian. And now, since this is a synthetic data set, we've actually made it such that age and experience are very highly correlated, as you can see there. Again, the car package has a nice scatter plot function. Which includes box plots on the margins, and then a 95% confidence band around the least squares regression line. So we'll get into some of these more fancy visualizations and all of that in later weeks. The point of today was to do a couple of things. First off, just get you situated with R and RStudio. Second, show you how to get data into R. And again, we call this a data frame, this special type of data set, which does everything we've come to accustomed to data sets having. Right? It shows us if it's numeric, if it's not, has the ability to have code mechanisms in there, and then also showed you how to save some other stuff and do some of the crude descriptive statistics that kind of underpin a lot of our analysis. Now, remember, in this course, all the code, or most of the code, is going to be written for you, but you have the option of kind of taking this really seriously, following through with the tutorials, and by the end, you'll be, very, very good, and might go on to take one of the other courses that we offer in R. Okay, so I'll say goodbye to you for this week, and look forward to showing you a little bit about linear regression next time. Thanks.